Right, so yesterday it was Quincy Jones, by the way, who composed that music, and Matt Monro was the singer, and the film was The Italian Job, so absolute classic. Today, I'm thinking more about what's good music to work to, because I was trying to work to Quincy Jones and it wasn't really doing it for me, it was putting me off a little bit. So today, I'm thinking about what's this music here? Not exactly sure what it is, but I do know who wrote it. It's Johann Sebastian Bach. Absolutely fantastic, probably the top of the composers to be a good one to be listening to whilst you're working, so that it sort of encourages your mind in the right way when you're doing your maths. Okay, so let's move on to have a little look today at the laws of logarithms. Question 7 yesterday gave you these three. Now you should have got 1 for all of these, because 2 to the power of 1 is 2, 3 to the power of 1 is 3, 17 to the power of 1 is 17. And so what that does is that gives us the first rule of logs that I want you to write down so that you know, and that is that log a is always going to equal 1. So it doesn't matter what the number is, if you do anything to the power of 1, you just get the same thing. That's all we're saying there. Next up, you had the final question, question 8. So how many times does it happen to get to 1? So 2 to the power of 0 is 1. 3 to the power of 0 is 1. 17 to the power of 0 is 1. So what that means we can say is that log of anything 1 has to equal 0. So that is our second rule for today. Okay, I'd like you to find as powers of 4, please. 4 to the 3 times 4 squared. Pause, have a go. And hopefully, using your index laws, hopefully you've got 4 to the power of 5, because you have added the powers. Right, next, could you consider what is 4 cubed? Right, it's 4 times 4 times 4, which is 64. And 4 squared is 4 times 4, which is 16. Now, 4 to the power of 5, we should know is 4 times 4 times 4 times 4 times 4. But remembering we've got those two times together, one way we could write that would be to say that it's going to be my 4 to the power of 3, which is 64, times 16. Now, I want you to bear that in mind as you please rewrite as logarithms 4 to the power of 3 and 4 squared. Pause that, have a go. We should have log base 4, 4 cubed is 64, is equal to 3, and log base 4 squared giving us 16. So log 464 is 3, log 416 is 2. Now what if we were to add the two equations together? We could say we've got log 464 add log 416, and that's going to get us to 5, isn't it? And the log base 4 of 5, but that log to the base 4 of 5 is actually going to be, we could also call it as whatever we get when we do 64 times 16, which is your 4 to the power of 5, so let me just do that to the side on the calculator here, which is 1024. So we've actually got log 4 1024. Now that is our first law, and all we're doing really is following through on our basic index power laws, that you add the powers together. That's what we're talking about, because our answer here with our logarithms is the power, isn't it? So when we're multiplying powers, we add the powers, don't we? So when we're adding logs, these are our results, so we need to multiply those. So our basic law that you're going to be writing down now is that log ax plus log ay is always going to be equal to log a xy. And what's really important here, that's called the multiplication law. And what's really important, that always has to be the same, just as when we're doing power law, it always has to be the same base number to the power. It's the same here. Your base must be the same, the a's must be the same. And there's a knock-on one from this, that the same is going to be true, or what do you think is going to be true if we were to take instead? So if our resultant here is the multiplication of those two, when we take, it's going to be the opposite of that. So it's going to be that one divided by that one. And that is called our division law. And I've just got one more law to show you right now, and that's what's known as the power law. And the power law just comes from the same idea. If you imagine that I've got log a of anything, let's call it p, and I add that to log a of p, what would I get according to this? I would get p times p. And what's p times p? It's p squared, isn't it? So that would give me log a p squared. And we can also think about that in terms of what result we're going to get, because we're going to get that value plus that value in our final answer. So how many of these that we've got. So we can also call that 2 log a of p. And that's your basic power law. So if we write the power law out again, let's go for it. If it's log a x to the power k, then this is the number of times that we've got it here. We only had it 2, but it could be any number of times. So that k will become how many log base a's, giving us a result of x that we are getting, and that is called the power law. They all come from the same thing. Now we're going to have a little look at a few examples to get you going on this. Okay, here's our first example. Write as a single logarithm, log 3,6 plus log 3,7. Give that a go. So here we should just have log 3 stays the same, and then it's just 6 times 7, isn't it? Which is 42. So that gives you log 3, 42. Here's our next one. So this time we've got to take. So we're using the division law, and we know our base is 2, and then it's just a case of 15 divided by the 3, which you can probably do in your head and get log 5. So far, so simple. Here's the next one though. What the flip is going on this time? We've got two things going on. We've got the adding and we've also got the power law. So my hint to you, if you haven't already paused it and had a go, is use the power law to change each of these before you attempt to add those. So what does that mean? That means I'm going from this form back to that form. So I'm saying for that first one, 2 log 5 3, well that's going to be log 5 still, and we've got 3 squared. I'm just going to put that in a bracket so we don't worry about it too much. And then we're also going to do the same thing here. So we're log base 5, and it's saying it's 2 to the power of 3. So what do both of those mean? They mean 3 squared is 9, log 5 2 to the power of 3 is 8. And now that we've done that, all we need to do is use our multiplicative law and say 9 times 8 is 72, so that must be log 5 72. And here's your final one. It's just the second part you're going to want to sort out before dealing with the taking away. So the first part stays the same for now because we can't do anything to it until we've worked out what this is. So first of all, we're thinking, I know that means that this is to the power of 4. So I've got my log 10, and let's just keep that a half and just write to the power of 4 first of all. Now I just think about what a half to a power of 4 is, which is 1/16, isn't it? So that means I can rewrite this as log 10 3 minus log 10, easy for me to say, log 10 1/16. And the division law, when you're taking, means I'm going to divide the 3 by the 16th. So I'm going to write that again as log 10. I'm just going to put a bracket here and say 3 divided by 1/16. And think about that, it's not actually that difficult. State change flip, 3 times 16 is 48. So that gives us a final answer of log 10 48. Job done. Right, I've got a bunch of different examples to go through here of different things that can come up, and it can look like, oh, what is going on there? Have a little look at it. Before I explain, have a go, because it's easier than it might originally look. So here we've got all of these x, y's and z's have been multiplied together. So we're looking at the oh dear, I'm not getting these out well today. Multiplicative law. That's right, isn't it? Yeah. Okay, so we're looking at log a plus log a plus log 1 for x's, 1 for y's, 1 for z's. So for x, because it's x squared, that means that that squared could become the 2 at the beginning, can't it? So that's the power law. And then I'm going to add to that just my log a of y, and then I've got z cubed, so that's going to be 3 log a z, and that's all it is. Have a look at the next one. We're just dividing here, so the first thing to do is the one on the top, the x, so that's going to be log a x. And because I'm dividing, that means I'm going to be taking away. That's y cubed, so that means I'm going to have 3 of my log a y's. Done. On to the next. So, all looks a bit confusing. That is a z, by the way, at the bottom, not a 2. So if I start with my x, these ones are being multiplied, so we're going to be adding for those, and then we can worry about the divide afterwards. So we've got log a x, and then it's a square root. Well, a square root is a power half, so for that reason we'll have a half log a of y. And then we're going to be dividing, so that means we're going to have to take the log a of z at the end. Right, then this last one's a little different because it says it wants it in x, y or z, but we've got an a down here. What does that mean? Well, don't worry, first of all, deal with the x. And then I'm going to be taking, so what is this? Well, let's just carry on and do it as if they'd said that I could have a's in there. A of a. Now, don't we have a law about this? What this is saying is I'm doing this number to a power of something and I'm getting the same number. So that power must be 1. So what that means is that this is worth 1 and I've got 4 of them. So what that means is all of this is just worth 4. So log a x take 4, and that's done. Next up, we've got an equation. Have a look. Now, that looks like, ooh, how are we going to solve that? You don't need to know anything new. Start off using your multiplicative law, because when you add those together, you know that's going to give you the same thing. Now, before we can do that, we better get that into that, hadn't we? So that into that. What are you talking about, God? Well, what I'm talking about is using the power law, so that I've also got this as a basic base 10. So that's the same thing as saying that, isn't it? That's how many times that's squared. So we're saying all of that is going to be equal to 2. Now we can use the multiplicative law so that we end up with a single logarithm going on. So that times that, isn't it? So that'll be 4x squared is equal to 2. How does that help? Well, I know this is the base, this is the power, and this is the result. So what this is saying is 10 to the power of 2 is 4x squared. So then I can say 4x squared equals 10 squared, which is 100. So then if we divide all sides by 4, we get x squared is equal to 25. And then if we find the square root, we've got x equals 5. Now there may be one or two of you thinking, oh, we should have said minus 5, but log 10 of the x is only defined for positive values of x. So x equals negative 5 can't be a solution of the equation. So we're just worried about the positive. Okay, here's our final example, and then I'll let you get on with some real good solid practice, because I think it's going to need it. Right, have a little look, see what you think. Because it's taking, therefore we're looking at the division rule. So we can say that log 3, now don't worry that it's a bit complex, just write it in as it is, x plus 11 divided by x minus 5, put that in a bracket for now, is equal to 2. Now, what do I know? I know that this is talking about powers of 3. We're talking 3 squared is going to be equal to that. So we just need to rewrite that without the logarithm. So we can say I've got x plus 11 over x minus 5, and that's going to be equal to 3 squared, which is 9. Now that I've got that, I can multiply both sides by x minus 5, gives you x plus 11 equals 9, x minus 5. Expand your bracket, solve that simple equation. So you should have x plus 11 equals 9x take 45. You're then adding 45, and taking x, which on this side should give you 56. Taking x from 9x should give you 8x, dividing by 8 we covered a couple of lessons ago, gives you 7. X is equal to 7. Right, now as I said, we're going to need a bunch of practice on this, so I reckon all of exercise 14E will be time well spent. Okay, well done folks, see you tomorrow.